Hello, dear students. Welcome to the Quantum Guru. Let's see this question number 3.20 of Irodov. The question states 2-point charges Q and minus Q are separated by distance 2L. As shown in the figure, find the flux of the electric field strength vector across a circle of radius R. And the line joining the two charges are along the axis of this circle. So this question we can do in two ways. One way is to find the electric field at some point in the plane of the circle, and then find the flux because of the resultant electric field. For that, we'll take the ring as element whose radius would be R and thickness would be dr. And then integrating over all the flux, we will get the total flux. That is one way. And there is another way by which we can do the answer fast by applying two principles. One is the superposition principle, and the other is the concept of solid angle. So the integration method I'll be needing in a next question, or maybe one or two questions later. So here right now I am going to use a very good method, that is the solid angle method. So let's first understand what is a solid angle. So what is solid angle? Like we know the plane angle, the sum of all angles in a plane at a point is 2 pi radian. Similarly, there is a 3D angle that is called solid angle. So for example, suppose this is any curve, and this is some point. If I join each point of the curve to this point like this, like this, like this, like this, like this, and like that, so I will get this kind of a solid angle. And that is the basic idea of solid angle. So this solid angle, this is at this point. And if I similarly take the solid angle, all solid angle at this point from all direction, that sum comes out to be 4 pi steradian. So we will be using a result of the solid angle. Here this curve was any arbitrary curve, so I joined any point of this arbitrary curve to some external point P, then I got this solid angle omega. So now the curve would be a simple curve, that would be a circle, and the point at which I'm going to join the lines, that will be on the axis of that ring. So like that. So here is a circular ring, and this is a circular ring, and this is a point on the axis. And if I join all the points of the circle by line to this point, so I will get this solid angle. Suppose this solid angle is omega, and this becomes a right circular cone, and suppose the half angle of this right circular cone is theta, and the distance of the circle to the vertex of this cone is say x, and the radius of the circle is say r. So solid angle subtended by all the points of the circle to this point on its axis is omega, given by omega is equal to 2 pi 1 minus cos theta. And you can see the boundary values. If you put theta is equal to pi, it will span the half space like this. And if you put theta is equal to pi, the solid angle will come out to be how much? If you put theta is equal to pi by 2, so it will span half the space. So in that case, this omega will be 2 pi. If you take theta is equal to pi, this theta goes to pi here, and this theta will go to pi here, pi like this, then this will span the whole space. So at that point, total solid angle, sum of the total solid angle, if you put theta is equal to pi, that will come out to be 4 pi. So it is being justified. So we'll be using this result to find the solid angle, find the flux because of a point charge. So once again, suppose this is a point charge. This is a point charge Q. And if I take any arbitrary surface, say S, so total flux crossing through this arbitrary surface, we know from the Gauss law that flux is equal to phi is equal to Q by epsilon naught. And flux is proportional to number of field lines crossing through a surface. So because if there is no other charge, it is an isolated point charge. So from that point charge, electric field lines radiate in uniformly in all directions. So total number of field lines radiating here are spread in the 4 pi solid angle. So number of through that 4 pi solid angle, total flux crossing is q by epsilon naught. So if I ask you how much flux is crossing through unit solid angle, and that would be phi by omega. So how much flux is crossing at a solid angle, say omega, about this? So through this, I mean at this part, how much flux is crossing, and that flux phi dash would be simply phi into omega divided by 4 pi, and that is equal to q by epsilon naught omega divided by 4 pi. That much flux would be crossing through within this region of solid angle phi. Now we are ready to solve this question using this concept and one more concept, that is the superposition principle. What is superposition principle? It says that resultant electric field at a point because of so many point charges is the vector sum of the electric field because of the individual charges that would be there if there were no other charge. So so here because of this, we'll find the flux first when minus q was not there, and when plus q was not there, then we'll find flux because of the minus 2, and we'll add the 2 flux. So this ring, all the points of the ring is making, say, some solid angle phi at the location of the point charge plus q. So this is suppose solid angle omega, and the half angle is theta. Similarly, on the minus q charge, by symmetry, it looks that the same solid angle will be subtended and the same half angle theta will be there, and we'll be using this formula. Omega is equal to 2 pi into 1 minus cos theta. Because of the positive charge, the field lines will be crossing along this direction, and because of the negative charge, field line will also be crossing towards this direction. So if observer is here, so for this observer, the flux because of the both individual charges will be positive, so the overall flux will be additive. And flux because of positive charge and flux because of negative charge both are equal, as you can see from the problem, and that flux is equal to, from this formula, q upon epsilon naught omega divided by 4 pi. And how much is omega? Omega is 2 pi into 1 minus cos theta. And how much is cos theta? You can see from this diagram, this is a radius r, this is L, and this would be square root of L square plus R square. So cos theta is L upon a square root of L square plus R square. So if I take this L outside the square root sign, so that will become that L and L will get cancelled. So that will simply become 1 minus 1 upon square root of 1 plus R square by L square. And just put the value of this omega here, and you see one thing. Overall flux is equal to flux due to positive and flux due to negative. And if I put that, so that will become q by epsilon naught into total omega by 2 pi. So omega by 2 pi, if we put here, so we will get q by epsilon naught into 1 minus 1 upon square root of 1 plus R square by L square. And this is my answer. Thank you.